Well, so the last problem we did on locus was this. From this assignment, the problem number 9. So other problems also you can attempt. At least some of them you can attempt. One or two will be little difficult, I understand. But other than that, most of it you will be able to do. Now today we will do on parametric representations, locus of points which have parametric representation. So find the locus of the variable point at square comma 2at, where t is the parameter. This is the first one. So find the locus of the variable point. So the variable point is at square comma 2at, which is the parameter, t is the parameter. So now locus means we have to write in terms of x and y equation. So let x comma y be equal to at square comma 2at. So that is x is at square and y is 2at. Now eliminating t. So this is say 1, 2. All right. From 2, t is y upon a. So eliminating t by substituting this in 1. Eliminating t by substituting the above in 1. We get, all right, x is equal to at square, which is a into y upon 2at whole square. So we get x is a times y square upon 4a square. So take this 4a square, this a cancels a square a times, and then this 4a you take to the x side and the other side. So we get y square is equal to 4ax. So this is the equation of the locus represented by the parametric point. Okay. So t is a parameter. T, you keep changing values 1, 2, 3, 4, 5. Accordingly, x and y points keep changing. And you trace all those points, we get this equation y square equal to 4ax. So therefore, the equation of the locus is y square is equal to 4ax. All right. Got it? So next, all right. So the variable point is t plus 1 by t comma t minus 1 by t, where t is the parameter. Find the equation of the locus. So find the equation of the locus of the variable point t plus 1 by t comma t minus 1 by t, where t is the parameter. So how do we do? How do we do? Please tell me, any of you. Malini, Chaitra, please tell. What is that to be done? We have to eliminate t. So what should you do? Let x comma y be equal to t plus 1 by t comma t minus 1 by t. So therefore, x is t plus 1 by t and y is t minus 1 by t. Now what do we have to do? Eliminate t from 1 and 2. How do we eliminate? How can we eliminate? Any idea? Yes, no, at least some answer I need.
No, sir.
Chaitra?
No, sir.
So you observe, this is t plus 1 by t, t minus 1 by t. If we square, if I square, x square will be t plus 1 upon t the whole square. This becomes t square plus 1 upon t square plus 2t into 1 by t. 2t into 1 by t. A plus b the whole square. A square plus b square plus 2ab. So we get t square plus 1 by t square plus 2. Okay. Similarly, y square will be t minus 1 by t the whole square, which is t square plus 1 by t square minus 2t into 1 by t. A minus b whole square is a square plus b square minus 2ab. So we get t square plus 1 by t square minus 2. Clear?
Yes, sir.
So now tell me, how can we eliminate t? So 1 and 2 have been transformed. How will we eliminate t? The term t has to be eliminated. So t square plus 1 by t square is common, right? For both. Okay. So subtract. Subtracting 2 from 1, squaring and then subtracting 2 from 1, we get x square minus y square is directly I can write. I'm just writing steps for you. These are direct. Now what happens is t square plus 1 by t square and minus of t square plus 1 by t square cancels. And then 2 minus of minus 2 is 4. So you get x square minus y square is equal to 4. So t has been eliminated. So this is the equation of the locus. Clear?
Yes, sir.
Hmm. So it requires elimination only. Question 3. Temporarily, we will cover the solution. Hmm. So if A, B, C are vertices of a triangle ABC, find the locus of the centroid if theta varies. So please tell me how to do.
By using centroid form.
Centroid formula. So let the centroid be G x comma y or h comma k. H comma k you should replace by x comma y at the end. Okay. Or if you directly want to write, this is the variable point. Let the centroid be g h comma k for the triangle ABC. Now, so x comma y or x will be x1 plus x2 plus x3 by 3. So cos theta plus sin theta plus 1 upon 3. Okay, this is 1. Next, y will be sin theta plus cos theta plus 2 upon 3. y1 plus y2 plus y3 by 3. Now theta is varying. Now we have to eliminate theta. How do we do? How do we eliminate theta? So theta terms should be eliminated. If you eliminate the theta terms, the resulting equation that you get will be the locus. You have, irrespective of theta, you have found the equation. So that means that particular equation, all the points will lie on this equation. So how will you do?
We can do x minus y.
Good. See, very simple. Do 3x minus 3y. So 3x is equal to cos theta plus sine theta plus 1. This is the equation 1 transformed. 3y is sine theta plus cos theta. They both are the same thing. Cos theta plus sine theta is same as sine theta plus cos theta. So 3x, 3y, cos theta plus sine theta plus 1 plus 2. Now subtract. So subtracting, say 1 minus 2. So 3x minus 3y is cos theta cancel, sine theta minus sine theta 0. So that also cancels. So 1 minus 2 is minus 1. So you get 3x minus 3y plus 1 is equal to 0. This is the equation to the locus. Okay. Got it? So problem is not difficult. It is just a matter of practicing. So let's look at the solution. 3x minus 3y plus 1 is equal to 0. That's what we got. All these questions are important, all the three, for practice. That's why I'm making you do. Find the locus of the point parametrically represented as this. So this requires trigonometric relations. So do we know all the trigonometric relations? Trigonometric identities?
No, sir, I don't know.
Hmm?
I don't know, sir. Sine square theta plus cos square theta is equal to 1.
This you know, Malini?
Yeah, only this one.
So suppose we divide this by cos square theta throughout.
Tan square.
So you will get tan sine square theta by cos square theta will be tan square
Tan
theta.
square theta plus secant square theta is equal to 1.
No, tan square theta. 1 plus tan square theta is secant square theta. Now the same thing we divide by sine square theta. You will get 1 plus cot square theta is 1 by sine square theta is cosecant square theta. Okay. So now we need to eliminate. So here we have secant and tan. So what is the identity we can use to eliminate? Just like when you do sine square theta plus cos square theta equal to 1, you eliminate theta. Irrespective of theta, if you can put these ratios, you will get. Similarly, tan square theta, no, secant square theta minus tan square theta will give you 1. from the second. So now find the locus of the points parametrically represented as this: a minus b secant theta and a minus b tan theta. So let x comma y be equal to a minus b secant theta, a minus b tan theta. Okay. So what do we do? So x is a minus b secant theta. So x minus a is equal to minus b secant theta, which implies secant theta is x minus a upon minus b. So secant square theta, x minus a the whole square by b. This is 1. Next. So y, now y is equal to a minus b tan theta. So y minus a is equal to minus b tan theta. So tan theta is minus of y minus a upon b. So tan square theta will be y minus a the whole square upon b, b square. I'm sorry. Not there, here. Okay. So this is 2. Now trigonometric identity states secant square theta minus tan square theta is 1. So this gives us x minus a the whole square upon b square minus y minus a the whole square upon b square equal to 1. Implies x minus a the whole square minus y minus a the whole square equal to b square. This is the equation of the locus. Okay. Understood how we did? Sometimes we have to use this. Fundamentally, these three we can use and eliminate. So x minus a whole square minus y minus a whole square equal to b square. Now let's do the second one. X is 2 secant theta cosecant theta. And 2y is secant square theta plus cosecant square theta. This is very simple as far as I can see. So yes, how to do this? Just try.
By converting secant theta into cos theta. Reciprocals.
Okay. Okay. Try that. Try that and give me the answer. Try it in your book. Please give the answer. Malini, are you able to do it?
No, sir.
Attempt. A large part of learning uh, maths is this. It's nothing great. It is just manipulation. Chaitra,
Sir.
say this. X is 2 into 1 by cos theta into 1 upon sine theta. Now y is 1 upon cos square theta plus 1 upon sine square theta. Okay. So here x, see from here we will get cos theta into sine theta is equal to 2 upon x. This is the first equation. Now from y, you bring this to common denominator. You get sine square theta plus cos square theta divided by cos square theta sine square theta, right? The numerator will be 1. It's an identity, trigonometric identity. Sine square theta plus cos square theta is 1. The denominator is cos square into sine square. That is cos theta into sine theta, the whole square. That will be 2 upon x, the whole square from 1. All right. So we get y is equal to x square upon 4. So x square is equal to 4y. That's the answer. All right. X square equal to 8y. This is
Sir, their equation 2y given na, sir. 2y
okay.
is equal to secant square theta.
Okay. So this is 2y. So 2y. So 2y is equal to this. 2y equal to this. So x square is equal to 8y. Correct. Got it? Clear?
Yes, sir.
Yes.
Clear, Malini? This was
Yes,
not
sir.
difficult at all. Just a little idea we have to get. And in maths, you will not get ideas unless you practice. Unless you practice, you will not get ideas. It is just with a certain amount of practice, you will know, okay, we have to take steps like this. So after some time, your mind will automatically work. But for that, you need enough number of enough practice. Similarly, now cosecant theta minus sine theta and secant theta minus cos theta. How to do this? How to eliminate theta to get the locus?
By using reciprocals.
Which reciprocal? Reciprocal of what?
Cosecant theta 1 by sin theta.
Okay.
Secant theta 1 by cos theta.
Okay. Then what to do?
1 minus sin square theta by sin theta.
Okay. All right.
Same way
1 minus sin square theta cosecant square theta.
1 minus sine square theta is what?
Cosecant square theta.
Cos square theta.
Cos square.
This is
Yes,
cos
sir.
square theta.
By
Okay.
sin.
This is 1. Similarly, y we'll
1
write
minus
as 1
cos
by
theta.
cos theta by minus cos theta. This will be 1 minus cos square theta upon cos theta. This is sine square theta upon cos theta. Now this is cos square theta by sine theta and sine square theta by cos theta. This is a difficult one to do now. How to eliminate? We have to use sine square theta plus cos square theta equal to 1. It's a difficult one to eliminate. This one is a little tricky. If I add, I get cos cube theta plus sine cube theta by sine theta cos theta. That is even more difficult. If I multiply, what do I get? Cos square theta by sine theta and sine square theta by cos theta. If I multiply this, I get cos theta into sine theta. Again, I get nowhere. So what should I do? So, but one thing I can do, suppose I square this and multiply. Then this cos square gets cancelled. I'll get purely in terms of sine square theta. So you see this x square times y. If I do, I'll get cos square by cos square theta upon sine theta the whole square multiplied by sine square theta upon cos theta. What do I get? Cos power 4 theta by sine square theta times sine square theta by cos theta. So what do I get? Sine square theta gets cancelled. This is cos cube theta. X square y is equal to cos cube theta. Okay. So which implies x square y to the power 1 by 3 is cos theta. This is equation 3 after this multiplication. Similarly, x y square will be cos square theta upon sine theta times sine square theta by cos theta the whole square. This will be cos square theta by sine theta times sine to the power 4 theta by cos square theta. All right. So what happens? Cos square theta cancels and we get sine cube theta. So this implies x y square to the power 1 by 3 will give me sine theta. Now from 3 and 4, from 3 and 4, eliminating theta using the identity. Cos square theta plus sine square theta is equal to 1. So square and add. So when we square and add, squaring this will give us x square into y to the power 2 by 3. Correct? A power m whole power n is a power mn. So a is x square y whole power 1 by 3 whole power 2. That will be x square y whole power 2 by 3 plus x y square whole power 2 by 3 is equal to 1. So this is the answer. This is the equation to the locus. All right. Is that clear?
Sir. Yes, sir.
So these were parametric, and you will come across problems like this again and again in coordinate geometry. All these problems, it is not that they are just random. They are well-framed problems in coordinate geometry, and you will come across these again and again. All right. After locus comes the important chapter.
Sir, I have a doubt, sir.
Yeah.
Sir, actually, locus, find the equation of locus parametrically. What is the difference between them?
I didn't understand your question. Again?
In the first questions, we did find the equation of locus. And then again, now we are doing find the equation of the locus parametrically.
Hmm.
What is the difference I wanted to know?
Just a second. See, in the first type questions, the, the questions of the earlier type, there were some conditions given, right? There are conditions given like this. Find the equation of the locus of P if the line segment joining these 2 points subtends a right angle at P. So we assume the point and then apply the conditions. When we apply the conditions, we get an equation and we replace h by x and y by and k by y. So we get an equation of the locus. This is the equation. The equation of a curve in xy coordinates will be in terms of x, y, and some constants. So this is the equation you have got. Okay. So all the previous problems were some condition is given and find the locus of the point. Now, after doing all those problems, we are looking at another type of problem where a curve is represented simply by one point like this, 80 square comma 280. This represents a curve. You keep changing the values of t, you will get points, and you plot those points, you will get a curve. So that is the locus. Locus of all, so it's set of moving points. You can say a point moves in such a way that it forms a curve. So t is a parameter. Parameter means t changes. Now t, x is equal to 80 square, y is equal to 280. Okay. Now put t equal to 0. If we put t equal to 0, what point t equal to 0, x will be equal to 0. Y will be equal to 0. Put t equal to 1. X will be a into 1 square. That is a. Y will be
2a.
2a. All right. Then put t equal to 2. X will be
4a.
4a. Y will be 4a. Put t equal to 3. X
9a.
is 9a. Y is equal to
6a.
6a. Put t equal to -1.
X is equal to a.
Hmm.
Y is equal to -2a.
Yes. Put t equal to -2.
-4a.
4a.
-4a.
4a minus 4. So as t changes, x and y change. Okay. As t changes, x comma y changes. And you can plot the point. Just let us show that. Let's see if I can demonstrate this. A t square 2a t. Got it? It's already plotted it. Now, A value, it is fixed at 1 and it has plotted. Okay. So this is the locus. It has plotted this 80 square comma 280. As t keeps changing, you get different values. Okay. For a equal to 1, you get this. If a changes, the parabola changes. Okay. Did you understand, Malini?
Yes, sir.
So next, the concept of transformation of axis. Okay. Now, transformation of axis is something very, uh, very important to use in physics and many mathematical problems. But it has a tremendous application in physical concepts. So, suppose in this is the coordinate axis, this is the origin. Okay. Now there is a point A in the origin, in the plane. Now, suppose there is another point B. See, origin is some point that we have fixed randomly. And after that, we drew x-axis and we drew y-axis. So let us say this point is uh, A, A, this is 1, this is 2, and this is 1, 2, 3, 4. So A is this point 2, comma 4. Now, what happens if I choose an origin somewhere else? Suppose I choose my new set of axes like this. Suppose my origin were this new origin. Now, with respect to this new origin, how will the coordinates of A be? Suppose I shifted with respect to the old coordinates, the new origin is at h comma k. In terms of the old coordinates or the old reference axis, it is h comma k. With respect to the new one, it is 0 comma 0. Okay. So how do I understand? How does my coordinates change? How does my coordinates change? This problem is extremely important in problems of physics. All right. Now, just imagine a pilot is on the ground. Okay. And he's taking off. Now he has to reach one particular point. With this as the base origin, he has to cover this much distance. Okay. Now, how he will, so this is one set of coordinates, this other set of coordinates. Okay. Now, when he goes to the top and he has to land, now with respect to the top, if he puts this as origin, now he is looking from here, then this point, what will be the coordinate of this point? What will be the coordinate of this point? where he has to land. These are very important. These are fixed within the navigation system of the airplane. Okay. So from different points of view, things appear differently. All right. Okay. From different points of view, things appear differently. So your coordinates of where to set will have to change from different. Suppose, uh, let us say a game, two people are playing a shooting game. Okay, shooting game and or bow and arrow game. Now they set a very high target. They stand at a distance of 5 meters, and there is a large pole, very huge pole. This is 5 meters, and let's say this is 20 meters. Now they have to hit this target. Okay. Now if they have to hit this target, this is the origin now. And they have to hit this target. So what is the angle to set? And what is the speed to set? Okay. If they have to fire an arrow to hit this target, they will have to see. The same thing, let us say, uh, you know, there is a building here, and from the first floor of this building, which may be 10-meter high, which is at a distance of 3 meters from here. So from this point, I have to hit the target. So now my coordinates change, right? If I see this as the origin, this will have a certain set of coordinates. If I see this as the origin, I make this as point as the origin, this will have the same point P here, the same point P, the target point, will have different set of coordinates with respect to the different origins. Okay. So the question is how to find, how to relate the same point with respect to different origins. The same point P, what will it have the coordinates with respect, coordinates X and Y with respect to the old reference axis, and what will it have with respect to the new reference axis. Okay. So this is a important question which we all need to which is extremely useful in most problems in physics. So this section that we do, um, we talk about how to study the coordinates of a point with respect to different coordinate axes. So there are three possibilities. There are three possibilities of transformation of axis. So transformation of axis, AX, ES means the coordinate axis, X and Y axis together. The plural of AXIS is AXES. So the first is translation. In translation of axis, the origin is shifted to another point without rotating the coordinate axis. That is, the x-axis and the y-axis in the new system are parallel to the old system. To the corresponding axis in the old system. Okay. So this is called translation. Second is rotation of axis. Now in this, the origin is not shifted. The origin is not shifted. But the coordinate axis are rotated by an angle. And third type of transformation is both translation and rotation. So there are three kinds of transformation of axis. So the first one, okay, so let's say this is the old coordinate axis and this is the new coordinate axis. So the axis remain parallel. This is the old origin, this is the new origin. So this is called as translation. This is translation. Now, let us say you have the old coordinate axis. This is the old coordinate axis. And the new coordinate axis so the x-axis is rotated. So both the axes are rotated by an angle theta. So this is called as the rotation of axis. Now, both the third case, translation and rotation, means you shift to a new origin, O dash, and then again there you rotate. Okay. So this is the third. Now, our point is, suppose there is a point P. With respect to the old axis, what is the coordinates of point P? And with respect to the new axis, what is the coordinates of point P? Now, similarly here, suppose this is the point P. With respect to old coordinates, what will be the, with respect to the old reference axis, what will be the coordinates of this point? With respect to the new one, what will be the coordinates of this point? So this is what we need to study. In the next class, we'll begin with this. I will want to take an extra class on Sunday. Tomorrow may not be possible. Sunday I will take, because Monday I may not be able to take class. So I will compensate for that on Sunday, and Wednesday also I missed. So I will tell you a time. Sometime on Sunday we will have a class. Okay.
Okay, sir.
I want